in which we discuss about what is force, its effects of force, different examples. We also discuss about the formula for force. That the formula was mass into acceleration. We also discussed that force is a vector quantity. Its SI unit is Newton. Then we saw that how 1 Newton is measured. 1 Newton is when 1 kg of mass is accelerated by 1 meters per second square of acceleration. And we also saw some examples related to application of force. Then we discussed what are the balanced and unbalanced force. And then we also discuss about the inertia. Inertia is the property of an object to resist any change in its state of motion along a straight line or rest. Then we saw the three types of inertia, that is inertia of rest, then inertia of motion, and then inertia of direction. Inertia of direction. And in today's lecture, we are now going to discuss the Newton's laws of motion. And there are total 3 laws of motion which are given by Newton. Okay, and in that we'll be discussing one by one. And first, we'll be talking about the Newton's first law of motion. Okay, so this law states that every body retains its state of motion along a straight line. This state of rest or motion along a straight line until an external force is applied on it. And this is called as the law of inertia. This Newton's first law of motion is also called as law of inertia. The statement of inertia is itself the statement of Newton's first law of motion. And in inertia, we saw that the what we saw in inertia, see over here, that it is a property of an object to resist any change in its state of motion, right? And check here, it is also the same, that every body retains its state of rest or motion. Retains means it will continue, it will resist the change, it will continue its state of rest or motion along a straight line until an external force is applied on it. And this applied force should be an unbalanced force. It is compulsory that the force applied on the body should be a unbalanced force. If a balanced force is applied, there will be no change in its state of motion, but there will be only a change in its shape and size. But when an unbalanced force is applied, we will see there is a change in its state of rest or motion. And to change this state of rest or motion, we need a unbalanced force. And if a unbalanced force is not applied, the body will retain its state of rest. अगर रेस्ट में है तो रेस्ट में ही रहेगी, और if it is continuing a motion, it will continue its motion. उसमें कोई भी change होगा नहीं. And this Newton's first law of motion is also called as law of inertia. It is also called as law of inertia. This is also equally important. Whatever statement it is there in the inertia, it is same for the Newton's first law of motion, because of which it is called as law of inertia. See, there is one example related to this Newton's first law of motion. It says that a person standing in a bus falls backwards. Falls backwards when bus starts moving suddenly. Imagine, say you are in a bus. If this is a bus and you are standing in the bus over here, and the driver suddenly accelerates in this direction, what happens? If you are standing, you tend to fall in the opposite direction, right? Right? Why? Why it happens that your feet are on the platform of the bus, your feet tend to move in the forward direction, that is in the direction of the motion of the bus, but your upper body is not in contact with the platform of the bus or any part of the bus, so because of which it tends to remain in the state of rest while your feet tend to move forward, and because of which we experience a motion which is pushing us in the direction opposite to the motion of the bus, because of which we say that. And we also experience that whenever we tend to stand in a moving bus and the bus moves suddenly, then we fall backwards. We'll see one more example, that if a moving bus stops suddenly, if a moving bus stops suddenly, the passenger tend to fall in forward direction. If consider that a bus is moving and someone comes in front of the bus and the driver applies brakes suddenly. So what happens in this case? If someone is sitting, even if he is sitting now, he will tend to fall forward. Why this happens? Because now the bus has stopped its motion, but along with the bus, the people or the passengers sitting in the bus were also in the motion. But in this case, what happens that only bus stops its motion, but the people sitting inside the bus will continue their motion and they will feel a jerk in the direction of the motion. Why this happens? Because the bus stops its motion, but the people in the bus will continue their motion, and because the bus stops, they experience a jerk or a sudden push as they were in the motion. To understand, if you are at the state of rest, you will continue to be at rest, and if you are in motion, you will continue your motion in a straight line. This is the statement of our first law of motion. And now we move on to our next topic, that is a momentum. Now, momentum of a moving body. Here, moving body is very important. Why? Because any body will gain momentum only and only if it is moving. If a body is at rest, if a body is at rest, there will be no momentum. Okay? And this momentum is equal to the product of its mass and velocity. So from this we get the formula for our momentum, which is mass into velocity. Make sure that you write this formula in your notebook. As velocity is involved in this, and we know that velocity is a vector quantity, so will be our momentum. Momentum will also be a vector quantity, and its SI unit is kg meters per second square. A kg meters per second, or kg comes from mass and meters per second come from the velocity, because of which we get the SI unit of momentum as kg meters per second. Understand simply, momentum is nothing but just the product of mass and velocity. For now, this is sufficient for you to know this. Now we'll move on to the Newton's second law of motion. Now, see, the rate of change of momentum, the rate of change of momentum is directly proportional. It's directly proportional to the unbalanced force. Unbalanced force applied in the direction of the force, and your word directly proportional is also equally important. Now what is saying? The rate of change of momentum means now what will happen? The momentum will change, and the change in momentum will be because of the change in the velocity of the object. See, your mass will always remain constant, whatever may happen. But if there is any change in the momentum, this change in the momentum will be because of the change in its velocity. बिकॉज जो मास है पूरे सिस्टम का, अगर आप किसी गाड़ी पे जा रहे हो और अगर गाड़ी का मोमेंटम चेंज होता है तो उसमें आपका मास कम ज्यादा नहीं होगा. The change in the momentum will be only and only because of the velocity. Okay, and this change in velocity means we can also change the mass and change the momentum. But in this case, which we are going to discuss, the change in the momentum will be because of the change in velocity. Okay, so now the rate of change of momentum of an object is directly proportional to the unbalanced force. Means if we increase the force, there will be the increase in the rate of change of momentum, and this rate of change of momentum is taken with respect to the time. It is taken with respect to time, and the direction of the force will be the direction of the change of momentum. We saw that momentum is a vector quantity, and as momentum is a vector quantity, it will have a magnitude as well as its direction. So whenever there will be a change in the direction, there will be change in the velocity, and we also have seen that force is also a vector quantity. It will have a magnitude as well as a direction. So the direction of the force will be same as that of the direction of change of momentum. So now we have seen the statement of the second law of motion. Now we'll check the equation of the this law. So now this law says that the force, this force is the unbalanced force, and we have seen that what are the two different types of force. One is a balanced force and another one is an unbalanced force. So this unbalanced force is directly proportional to the rate of change of momentum with respect to time. With respect to time, and we can also show this statement as F is directly proportional to dP upon dt, where dP is the change in momentum and dt is the change in time. Okay, so now to show this change in momentum, we can also say that it is equals to mass into the final velocity. We saw in the motion that V was showing us the V is the final velocity. V is the final velocity, and our U was the initial velocity, and U was our initial velocity. And whenever we try to calculate the change in anything, we always subtract the initial from the final, or we can simply say that we will do V minus U, the final minus our initial value. So from here we are calculating the final momentum, and as I said to you that the change in momentum will be because of the change in the velocity, as mass will be same in this system. So see, our mass is same, here it is also m, and here also it is m as it is, but we can see that there is a change in the velocity. First it was u, our initial velocity was u, and now it has changed to v, that is our final velocity, and with this we'll calculate the final momentum minus initial momentum with respect to our time t. And further simplifying the equation, what we get, we'll take the m common from this m into v minus m into u, and we'll get this equation that f is directly proportional to mass in bracket v minus u into time t. And in the chapter of motion, we saw that acceleration is equals to final velocity minus initial velocity into time period t. This was our first equation of motion, and we also see it over here. See, so from this we will get that force is directly proportional to mass into acceleration, and as it is directly proportional, we say that F is equals to mass into acceleration. Now you will say that our directly proportional sign is directly getting converted into the equal to sign, right? Where is the constant? Here constant is taken as 1. Constant is equals to 1. Now why only 1 and why not some other values? So it is because it is not dependent on any other value. मीन्स अगर उसमें कोई और फैक्टर नहीं है जिसके जिसके ऊपर हमारा फोर्स डिपेंडेंट है, इट इज ओनली डिपेंडेंट ऑन मास एंड और एक्सेलरेशन, बिकॉज ऑफ विच वी टेक द कांस्टेंट एज 1. Okay, now see, there are some points related to the concept of our force. It says that if acceleration is equals to 0, our force will be equals to 0. When acceleration is 0, our force will be equals to 0, as a mass can never be equals to 0. If we are applying the force on anything, if we are applying the force on anything, then that thing will have some or the other mass. There is nothing in this world which is without any mass. Everything in this world has mass. So if there is no acceleration in that body, then only we will say that there is no force. But if we start saying that as there is no mass, there is no force, then this statement will be false, because every body in this world has some or the other mass associated with it. Okay, so whenever there will be no acceleration, there will be no force applied on that body. Okay, and it also says that it means that in the absence of external force, in the absence of external force acting on the body, it either moves with constant velocity or remains at rest. It either moves with constant velocity, don't consider this, it will remain at rest. It means that in the absence of external force, the absence of external force acting on the body, it either moves with constant velocity or remains at rest. Okay, I see that Vishwajit is raising his hand. Any query, Vishwajit? Okay, so as we discussed in our Newton's first law, which said that a body will continue its state of rest or motion until and unless any unbalanced force is applied on it. So this is what it is coming over here, that in the absence of external force, the body will be either moving in a constant velocity or rest. And if there is any force, then that force will be directly proportional to the change in the rate of change of momentum, and that force will be equals to mass into or acceleration. And if there is no force, if F is equals to 0, or acceleration will be equals to 0, as always there will be some of the other mass of the body, or A will be equals to 0. And as our A is equals to 0, there will be no change in the velocity, and because of which we will see a uniform motion. Right? We will get a uniform motion. Uniform motion is possible when force is equals to 0. When force is equals to 0, our acceleration is also 0. As acceleration is 0, no change in the velocity, and whenever there is no change in the velocity, we always experience a uniform motion. Or if there is no motion happening, the body will always be at the state of rest. Okay, I hope it is clear now. Now, see, in a high jump athletic event, the athletes are made to fall on cushion bed or sand bed. This increases the time of the fall to stop after making the jump. What it does, it increases the time of the fall to stop after making the jump. This decreases the rate of change of momentum and hence the force. Now, we saw that uh, F was directly proportional to m e minus m u divided by t. We can see that our F is directly proportional to rate of change of velocity. Our F is directly proportional to rate of change of velocity, but it is inversely proportional to the time. A time is inversely proportional. See, it is 1 upon t. It means that whenever we increase the time, whenever there will be an increase in the time, there will be decrease in the force. It means that if we increase the time of or change of momentum, there will be decrease in the value of force, or force will start decreasing. And this is what stated over here, that in a high jump athletic event, the athletes are made to fall on cushion bed or on a sand bed. This increases the time of fall to stop after making the jump. This decreases the rate of change of momentum and hence the force. Okay. See this second. A cricket player moves his hand backwards on catching a fast ball. Moves his hand backwards on catching a fast cricket ball. This increases the time during which the high velocity of the moving ball decreases to 0. Now, whenever a cricketer tries to catch a ball during a match, he tries to move his hand backwards. Whenever he will catch a ball, he will try to move his hands backwards. And in this way, what he will do, he will decrease the time of the change of momentum. if a ball is coming towards the cricketer, if a ball is coming towards the cricketer, it will have some or the other velocity and it will also have some mass. So if there is velocity and also a mass, so it will have a momentum. Momentum is product of mass and velocity. And to stop this ball means he's changing the velocity. And because there is a change in the velocity, there is change in momentum. As the ball is the same, the mass will remain same. And if there is change in momentum, it will be because of the velocity of the ball. And if the ball stops at a higher rate of time, means the time taken is more. If the time is, if the time is more, the force will be less. If the time is more, our force will be less. And because of which the cricketer moves his hand in backward direction. I hope now the Newton's second law is clear to you. Now see, we'll be now starting with our Newton's third law of motion. And it states that for every action, there is an equal and opposite reaction. There is an equal and opposite reaction, and these both means what? This action and the reaction act on two different bodies. Acts on two different bodies. This acts on two different bodies is very important, and many a times questions are asked on this statement that the action and reaction defined in the Newton's third law of motion act on the same body or two different bodies. So because of which you need to remember this statement which says that for every action there is an equal and opposite reaction, and both acts on two different bodies. And this law is also called as the law of action and reaction, as action and reaction are involved in this statement. Okay, now see what are these action and reaction. While walking, a person presses the ground in the backward direction. We all walk, right? And while walking, every person presses the ground in backward direction, and this becomes our action on the ground. And in the reaction part, what happens? The ground pushes the person in forward direction. We were pressing the ground in backward direction, and the ground in the reaction part pushed us in the forward direction with equal force, making the person to walk. Now see, if you look at this diagram, the person is trying to walk, and in this the person is pushing the ground with his feet in this direction, in the backward direction. And as he is pushing the ground is also pushing him back. And as the ground pushes him back, the athlete moves in the forward direction. This pushing becomes the action. This pushing becomes the action, and this becomes our reaction. Okay, now understood. There is also one more example. See, a swimmer pushes the water backwards, and as he pushes the water backwards, this becomes his action, and the water pushes the swimmer forward. And as the water is pushed backwards, the swimmer is pushed in forward direction because of the pair of action and reaction. The action is acting on the water and the reaction is acting on the body of the swimmer, because of which he is pushed forward. Now also see the third statement. It is difficult to walk on sand because on pushing, it should be sand. Because on pushing sand, sand gets replaced and reaction from sandy ground is small. Now whenever we try to walk in sand, what happens? Our leg gets pressed into the sand and the sand does not give us as much reaction we give to it, and because of which we feel very difficult to walk on sand. The sand in this case cannot provide a sufficient amount of reaction, and because of which we, whatever amount of force we try to apply, it becomes less and we get a less amount of reaction, because of which it becomes difficult to walk on sand and we need more and more amount of energy to walk. So because of which we say that it is difficult to walk on sand. So this was our third law of motion. Now we'll discuss about the one concept, that is impulse. Now see, what is impulse? If a large force is acting on a body, if a large force is acting on a body for a short period of time, for a short period of time, then the product of this force and time, the product of this force and time is called as impulse, and this force is itself is called as impulsive force. This force is called as impulsive force. And we have the formula for impulse, which is impulse is equals to change in momentum, and this change in momentum is also equals to force into time. In the second law, we saw that R F was directly proportional to R F was directly proportional to mv minus mu divided by t, right? And if we multiply this t with f, what will it become? That force into time, force multiplied by time, and that we, and if we try to remove this directly proportional sign with our constant 1, which we discussed in the same law, that is second law of motion, we get that it is mv minus mu, mv minus mu, right? And what was this mv minus mu? This is our change in momentum, and we can see this, that this change in momentum, this force into time, is equals to this impulse, and impulse is also equals to the change in momentum. See this mv minus mu, it is the change in momentum, which we also discussed in the second law of motion, and this change in momentum is equals to force into time. Now as there is a force, now we know that force is a vector quantity, force has a magnitude as well as direction, so the impulse will also be a vector quantity, and its SI unit is Newton second or kg meters per second. And this kg meters per second is also the unit of momentum which we discussed today. This is also the unit of momentum, right? So a impulse is nothing but simply a change in momentum. And this change in momentum is calculated using the formula force into time. Okay, so now we'll see the application of the impulse. Now see the China wares. You see this image over here. This is the image of the China wares. The China wares are wrapped in paper while packing so as to increase the time of impact. To increase the time of impact while which will reduce the impact force acting on it and prevents it from breaking. Now, if we know that the change in momentum is going to be fixed. If this is fixed, we can say that F is inversely proportional to D, and if time is increased, our force will start decreasing, and as the force acting on the body will decrease, the impact which will be created due to this force will also decrease, and because of which this China wares will be safe.